Chapter 6, Section 2 is about properties of parallelograms. So by the end of this lesson, you should be able to prove and apply properties of parallelograms, and then you should be able to use the properties to solve some problems. So a parallelogram is just a special type of quadrilateral, and it happens when you end up with two pairs of parallel sides. So your opposite sides are parallel. So you have A, B, and C, D, the red ones here, and then the blue ones that are parallel to each other. And we have a new symbol. How we write the triangle in front of our triangle letters, we write a parallelogram in front of our parallelogram letters. So here are your properties. For all parallelograms, the following things are true. Opposite sides are congruent, opposite angles are congruent, consecutive angles are supplementary, and the diagonals bisect each other. So here are the theorems. If a quadrilateral is a parallelogram, then opposite sides are congruent. So the red sides and the blue sides. If it's parallelogram, then your opposite angles are congruent. So your blue angles and your red angles. If it's parallelogram, then your consecutive angles are supplementary. So this works like B and C have to add up to 180, and D have to add up to 180, but then also A and B and C and D. So you have 4 sets of supplementary angles. And then if it's a parallelogram, then your diagonals bisect each other. So BZ is the same as ZD, and AZ is the same as ZC. So let's prove one of them. I'm going to give you a parallelogram, and you got to prove that your opposite sides are congruent. So let's write our 2-column proof with our statements and our reasons. So the only thing they give us is that JKLM is a parallelogram. So once we know that the opposite sides have to be parallel. We don't know yet that they're congruent, but I know that JK has to be parallel to LM, and that KL has to be parallel to JM. And that is because it's a parallelogram. So definition of parallelogram. So now they kind of set this up for us. They have the one diagonal there, and they have these angles measured. So remember when we were doing triangle proofs, we talked about they wouldn't tell you things are parallel unless you have to use one of our angle theorems. So pretend that these extended forever and ever because they're really just lines. And if this was our transversal, we have congruent angles here. I know that angle 3 has to be congruent to angle 4 because of alternate interior angles. And then if we pretend that these other ones go on forever and ever and still add this as our transversal, now I know angle 2 and angle 1 have to be congruent. Same reason, alternate interior angle theorem. So then we can kind of look at this as one of our triangle proofs. This right here is a triangle, and the one down here is a triangle. Remember what I said, if they have a side that overlaps, we're going to have to use the reflexive property. So I know that JL has to be congruent to JL, this one right in the middle. And that's because of our reflexive property of congruence. So now I have enough information to prove that the top triangle is congruent to the bottom triangle by angle side angle. So I know that triangle KJL has to be congruent to triangle MLJ because of angle side angle. So now that I know that, I can use CPCTC to prove that any parts of those triangles are congruent, which is what we're going to do. I'm going to prove that this side over here is congruent to this side over here. KJ has to be the same length as LM. But then also the top and the bottom have to be congruent for the same reason. KL is congruent to MJ because of CPCTC. So that proves this very first theorem that we had, that opposite sides have to be congruent. So let's use that information. I gave you a parallelogram. Tell you some information. The distance from L to M is 28 inches. Tell you that L to N, so this diagonal here, is 26 inches. And then this angle, LKN, is 74 degrees. So if they ask you for KN, that's across from this 28. Remember, these have to be congruent. So I know that's also 28 inches. And NML is this one up here. And remember, these are congruent. So this has to be 74 degrees. Now this one's a little trickier. I only want L to O, this little section right here. But remember that this and this are congruent because the diagonals bisect each other. So if the whole thing's 26, I only want a half of it. I only want 13 inches. So let's do one that's a little harder with some algebra. Find each measure. So from J to G is just this distance right here. We don't have enough information for that, but I know that this is congruent to this side over here. So that means that 3W has to be the same length as W plus 8. And if you do a little algebra, you end up with a value for W. And then all it takes is some more plug-in stuff in. 4 plus 8 will give us 12. FH is going to be found exactly the same way. It's this whole length right here. Again, we don't have enough information right now, but I know that these two have to be congruent. So I know that 4z minus 9 has to be exactly the same as 2z. So again, do a little algebra, move some things around. You end up with a value for z, 4.5. So if I plug that in, 2 times 4.5, I end up with this little piece right here, JH, being 9. So that means the total distance there has to be twice 9, or 18. Let's do a totally different example. If we're in a coordinate plane, we can use what we know about parallelograms to find a third or a fourth dot if they don't tell us what it is. So we have this parallelogram, PQRS. They tell us P, they tell us Q, they're missing R, but then they tell us S. So if we plot these on this graph, down or back 3, down 2, there's P. They tell us Q is back 1, up 4. R has to be somewhere in between Q and S, which is right here. So that means it's got to be somewhere up here in this general region for it to be a parallelogram. So think back to what you know about parallel lines. They have the same slope. So this is technically a line right here that goes through QP. I need to find a similar line over here that goes through S and somewhere up here connects that R that we're missing. So what we're going to do is find the slope of this. And we're going to find it just by counting. How many do you go up? How many do you go over? So up 1, 2, 3, 4, 5, 6, over 2. So the slope of PQ is up 6 over 2, or 3. We want to do exactly the same thing from S to find R. So we're going to go up 1, 2, 3, 4, 5, 6, over 1, 2. R has to be right here. So I can draw a line from our new points there, and then that automatically means that if I connect Q and R and P and S, those are going to be parallel also. So R is up here at over 7, up 6. So there is our missing vertex. All right, let's do one more proof. So we have these two parallelograms here. The only thing they tell us is that H and M are collinear and that N and K are collinear. So that just means that this is one line and this is another line, just telling you that it's not broken apart or you get two different segments here. So we need to prove that angle G, this one over here, is congruent to angle L, this one over here. So let's see what we're working with. Write down statements and reasons. So the first thing they tell us is that G, H, J, N, and J, K, L, M are parallelograms. And then they tell us H and M and N and K are collinear. Again, given. Alright, that doesn't really tell us much. We know that this angle and this angle here have to be congruent if these guys make a solid line because of vertical angles. So don't forget the thing about the triangles. If they have points that touch, that means that you end up with vertical angles. So I know that angle HJN is exactly the same measure as angle MJK because of vertical angles. And then we need to remember our definitions of parallelograms. If this angle is a certain measure, this angle over here has to be exactly the same. So I know that angle G is congruent to angle HJN because of, one of the properties that we had that said if you have a parallelogram, then opposite angles are congruent. And because of the same thing, I know that angle L over here is congruent to my other angle. So let's make a new column here. So I know that angle L is congruent to angle MJK for the same reason. Opposite angles are congruent. So then, if I know those two things, I can use the transitive property to say that angle G has to be congruent to angle L. And that's it. So you should be able to prove and apply properties of parallelograms and then use those to solve problems. Make sure you write down any questions you have and we can go over them in class tomorrow. Have a good night.